Shut up and sit down.
Okay, welcome to my first video in like 11 months. So the reason for the video is a new project series I want to start. Building a new CNC machine. So I got my CNC over there, kind of there, yeah, over there, behind me. It's not as capable as I would like. So what I've decided to do is build a new one. The new one is a lot more robust, like probably around 300 kilos in total. Made most out of steel tubing, proper size 20 linear rails, ball screws, pretty much same linear and ball screws that I have on my current machine. And then I'm going to run closed loop steppers on that. 3 Newton meters should be more than sufficient for the speeds and feeds I'm looking for. But yeah, we're going to hop into CAD. My pencil escaped. We're going to hop into CAD shortly and go over all of that. But for now, I thought I would just update the channel and say we're going to be going in a newish direction. I've stopped flying copters, so there won't be any more of that. It was an issue of me potentially getting in trouble for what other people were doing, and yeah, I was going to have none of that. Okay, so I've started acquiring things for my CNC machine. These are old parts out of some machinery we stripped down at work. Some of our actual machinery from about 10 years ago. But the connectors are still good, the LEDs are still good, these housing things are still good. So I'm planning on running grbl on my CNC machine, which runs off of an Arduino Nano. So what I'm going to do is I'm going to use these holder things, make up a circuit board that breaks my Arduino Nano out into a bus like this for inputs, for my limit switches, external communications like switches, probes, things like that, main power, and then I'll have 3 of these for my stepper motors, step and direction. So the next coming week or so, I'm just going to desolder all of these free headers, can't complain. And then on my current CNC, I'm going to mill up a new circuit board for breaking that out. I still need to actually design that. I might try my hand at it's an Eagle. I did try and design a board the other night and got very, very over it. But I might give it another try, or I'll just do it good old style, draw it all in AutoCAD and then mill it, like I've done before. I'm planning on putting indicator LEDs on my inputs and outputs, just that I can see for troubleshooting what exactly is happening. I'll probably look at it once and never again. But yeah, I'm going to put those in there. So those are my boards that are going to get scavenged. Yeah. Then I got these. So I got myself a set of these while I was out today, spending literally all money on dumb shit. Basically draw slides, 550 stroke. They are going to run the door on my CNC machine. So similar to the Skyfire door, basically the same kind of story. I'm going to have one down below, except I'm going to design mine a little bit smarter, where my plexiglass door will sit above it and there'll be a joiner plate, and I'll put a lip on the bottom one that's tapered, so that if any coolant runs to it, it runs forward. So when my door opens all the way, the coolant that's on the door will want to run down and back into my machine. So I got a set of those. They were like ridiculously cheap, like all of $4. And then I picked up one of these because everybody likes to see what they're machining. So I now have 2 of these 10 watts LEDs, which are going to go into the enclosure. The CAD model that you're going to see shortly is a real, trying to think how to put this politely, balls up. So I've been designing and iterating as I go in a single CAD model, and yeah, it's actually got to the point where it started to become a problem on my PC. But yeah, in other news, I got a really cool gift from my brother-in-law. These bastards, they're freaking amazing. Yeah, I like them. They're my favorite. Just random bit of info. Also got a green cutting mat to destroy. Yeah, so let's hop over into the CAD environment. I'll show you what the design looks like so far. And then I've also got a bit of footage of welding up the frame, the base frame of the machine, and popping a couple of holes in it so that I can hold it once I get it back from sandblasting and base coating, so that I can machine it. And then probably going to aim for a bi-weekly schedule on these videos, but who knows. maybe I'll push one out every week with small updates on the progress. This weekend I'm planning on machining a lot of the parts as well. So yeah, onto the CAD. Okay, welcome to the abortion that is my model. So I've got the floor modeled in here because reasons. Was calculating for the trolley, which is basically a universal direction trolley, so there's no casters in there, but it's made and the casters all swivel. So once it's underneath and gets dropped onto that trolley, I can move the machine omnidirectionally. This is the so far cover design. Don't really like it, so I'm just going to hide that for now, just so you have an idea what it's going to look like. There's where my electrical box is going, 400 by 400 by 200 electrical enclosure. Then onto the fun bits. So all the ventilation holes here are because it's a piece of material I had at work already. It's actually the same piece as that. So we had two of them that were from a previous project. It's 20mm ground plate. So I've salvaged it. I'm popping my own holes in between the existing holes so that I can repurpose it and obviously get it at a really good price. So this has got some reliefs to mount my BF block. BF, and then I'm going to be using an MBA 12A, MBA 12-C, sorry, that houses a NEMA 23 motor, and then a FF12C over here. That'll allow me to mount my ball screw and my motor concentrically, and saves me having to make a bracket. Not a cheap solution, but a lazy solution. I've got to put in a relief into that plate there that's not there. Right now I've just got clear parts in here because it's the model I had. I need to still do all my way covers on this. So my plan is to actually machine this plate on the weekend. And then a couple other odds and ends of some spaces and things that have to be made. I want to get that done this weekend. Next weekend I want to get the base machined for my linears. And also want to get the upright machined. And then the way covers, I need to finish designing and get them off to the laser guys, or laser and bend it for me, because that's my rear way cover. It's the only one that I'm actually happy with. So it goes like that. So underneath is still fully accessible, but generally shavings don't fall like that. I may tweak the angles a bit. But then yeah, that'll go back and forth, protecting my Y-slide that way. And then on the front, I've recessed my linears that I have a bit more space. There'll be an extension on here of probably about 100 mils to meet up with the enclosure, where I'll have way covers over the front here. Yeah, that motor moved. My model, like I said, it's falling apart. This is a temporary model of the Z-slide, but there's also got way covers. I'm pretty happy with those covers. So they overlap each other, and then there's obviously all the space down below these where they can sit. My travel on Z is 300. My travel on X is 300, and my travel on Y is 200. All of these have got an extra 10 mils built in for limit switches and homing, but machinable area will be 200 by 300. I still need to update this. I have material for the spindle housing, but it was shorter than I needed, so I had to redesign my spindle. We're going to open that now. This is a 0.75 kilowatt or 1 horsepower 3-phase motor. It's a 71B14, so it's got the small mounting flange on the front, and it's a 71 size motor. And then my Z motor will mount up there. I will be doing counterbalances on this, gas counterbalances, which will probably mount somewhere here down to the frame. I'm not entirely sure. This is not finalized. The only things that actually are finalized half are this and this plate. Those will be done in the next day, then I can move on to manufacturing. Material for the frame I'll only be getting in the new month. It's a 40 by 40 by 2 or 38 by 38 by 2 millimeter square tubing. It's quite over engineered, but why not? Then underneath we'll have a chip tray, something to this effect, with a drain here down to my coolant tank, which will sit move this thing over, which will sit over here. So it'll all drain down to there and then just get pumped back up. At least that's the plan. I'm not going to have any chip trays. My chips will just drop in. I'll have to manage that. It's just one of those things. Yeah, so the machine's going to be, like I said, it's going to run the 3 Newton meter closed loop steppers. And yeah, that should do the trick. I'm just going to open up the spindle quickly and turn on my analysis. So this is a R8 spindle that I designed. I looked at getting a TTS tooling system for it, but it was $300 for the system, which is fine for a couple holders and all the things I wanted. But by the time I got it to South Africa, it was nearly $800. So it wasn't worthwhile. So what I'm going to be doing is making my own similar system, but using a 16 diameter instead of a 19.05, just because that's the R8 collets I had available. This is built with angular contact bearings, not spindle bearings, because spindle bearings are 6 times the friggin' price. So I've got 2 down the bottom here, I've got 2 up the top. The nut will preload these bearings, preload this tube onto these bearings. So what will end up happening is we will preload these bearings. They're fixed in the Z-axis in this direction. These ones are free to float with a millimeter. So if the spindle expands, these bearings can move up and down, but they are constrained in the XY plane. The bottom bearings are constrained in X, Y, and Z. R8, that'll be ground, and then going to have a brass bush that I drop in there, I think, and then some domed washers to allow me to do a quick change. So ideally, I'll have either a lever or a cylinder up the top to release that. My spindle nose size is a little weird. It's a 92, but that was just to fit these huge bearings in. They're a 35 ID, but yeah, the OD is like 72 millimeters. It's really overkill. So that concludes the CAD side of this video. I think I may just break this into 2 videos just to make my life a little easier. So stay tuned for part 2, which will have the welding and machining more than likely.